Hello, welcome to Debug School. This time, Test Case Simplification Part 1. Sometimes you'll encounter a bug that's really hard to diagnose. The error message was not helpful or non-existent, but the behavior is decidedly wrong, and you have no idea where to look next. This is the kind of situation where I would turn to test case simplification, the technique that I'm going to show you in this lesson. This really is my secret weapon. It's what allows me to successfully diagnose the problems that often no one else on my team can figure out. It has routinely saved the day for me when I encounter the most difficult bugs to diagnose. To explain test case simplification, first let me define the concept of relevant code. In the context of a bug, relevant code is any code whose presence is required in order for the bug to exist in its current form. Removing relevant code makes the bug go away. Now, that doesn't necessarily mean you've fixed the problem, because removing some piece of code could create yet another bug entirely. But within the context of the bug in question, if by removing a piece of code that makes the bug's behavior go away, then that code is relevant. Conversely, if you remove a piece of code and the behavior of the bug remains the same, then that code is irrelevant. Given that, test case simplification is the process of systematically removing irrelevant code until all that is left is code that's relevant. Back in the day, Netscape Navigator had this bug where if the user attempted to print out a page, the browser would crash spectacularly. What's interesting about this story, though, is that the person who found the cause of this problem was not a Netscape engineer, but rather an open source enthusiast with very little programming experience. Let's call him John. John went and volunteered at one of Netscape's Bugathon events to help hunt down some bugs. Instead of telling you what he did, I'm going to sort of reenact it for you. So the first thing that John does is he opens up the problematic page. I actually don't have the version of Netscape which still contains this bug, so I'm just going to have to use Firefox as a stand-in for this demo. Ironically, the problematic page happens to be the issue page on Mozilla's issue tracker called Bugzilla. So John opens up an issue in Bugzilla, and now he tries to print that page. When he does, the browser crashes. Great. Bug reproduced, which is always the first step in trying to fix a bug. Then the next thing he does is he reopens the browser and does a view source on that page. He copy and pastes the code into a file called issue.html. To speed up this demo, I have prepared a little command line program that John can use to quickly test out what would happen if he tried to print out a particular HTML page. This program is called try_print, and he would give it the name of the file to print as the argument. The program will output either program crashed or OK if the page printed out without problems. So he tries to print issue.html, and it crashed, just as we saw happen in the actual browser. Just as a sanity check, he gets the source code of another web page, this time the Bugzilla front page, and he runs try_print on it. There he gets an OK. So now he knows that the problem is specific to the issue page. So he drills down into issue.html. He knows that if he removes some code from this file, and if it still crashes, then the code that he removed is irrelevant, i.e. it did not contain the cause of the bug. So he removes some link tags and runs try_print, and it still crashes. And he removes some more, and it still crashes. So he's working his way to narrowing the cause of the problem. But this file is huge. It's close to 2,000 lines. Doing this by hand, bit by bit, is going to take forever. But John has an idea. He's going to use a technique called divide and conquer, which works like this. He divides the file into two halves. the top half and the bottom half, and he deletes the bottom half. He runs try print, and it still crashes. So now he knows the bottom half must be irrelevant. He's just eliminated one half of the file. This is huge. And he can do the same thing again. He splits the rest of the code again into two halves, and he deletes the bottom half. This time when he runs try print, the browser didn't crash. That means that he removed the cause of the bug along with the bottom half of the code. So he needs to bring back the bottom half, and then he deletes the top half. This time the browser crashes, so that means that the top half of the code is irrelevant. And we still have relevant code. So that is how divide and conquer works. And John just repeats this process over and over again. He deletes the bottom half, gets an OK, so he puts it back and deletes the top half and gets a crash. Okay, still have relevant code. Subdivides again and deletes the bottom half, gets a crash. Okay. Subdivides yet again and deletes the bottom half. Another crash. He does the same thing once again and this time gets an OK, so he puts back the bottom half and deletes the top half. And now he gets a crash. Again does the same thing, deletes the bottom half and gets a crash. We still have relevant code. Now all of this work is repetitive and tedious. But look now, very quickly, John has narrowed it down to less than a page of code. He continues and he deletes the top half this time, and he still gets a crash. And now the problem is coming into view. He is looking at this select tag here, and to sort of zoom into it, he removes the containing div tag around that select tag, and it still crashes. So now he's thinking the select tag is the culprit. But maybe it has to do with some of the options within the tag, so he removes the option tags. And it still crashes. They are not relevant. He wonders where the multiple attribute inside the select tag is the culprit, so he removes that, and it still crashes. He removes the remaining attributes in the tag, and it still crashes. He then removes even the closing select tag, and it still crashes. As a sanity check, he removes the select tag altogether, and now he gets an OK. So, sure enough, the presence of a select tag, any select tag at all, is all that's needed to cause Netscape Navigator to crash. What a great ending to a mystery. John was able to pinpoint the cause of the bug by simplifying the test case. John updates the description of the issue to simply printing any page containing a select tag causes browser to crash. This saved the Netscape engineers lots of time, not only in pointing them to exactly what they needed to know to make the fix, but also in helping them triage and prioritize their slew of bugs. Now that you've seen the technique in action, I'm going to talk about its pros and cons. Let's start with the cons. As you have seen, this technique can be tedious, even with the divide and conquer technique. However, this technique has got pros in spades. First of all, it's simple and straightforward. You don't even need to know programming in order to use it. It's simply the process of elimination, which is a skill you've already learned in high school while you were taking multiple choice tests. Second, it always works. It will always help you narrow down the location of the problem by eliminating places where it's not. Third, this technique is universally applicable. You can use this technique with any programming language, platform, or framework. And finally, at the end of going through this process, you get a small reproducible test case which you can use to understand the root cause of the problem at a more basic level. And also, you can use it to communicate the problem efficiently to others if you're trying to add information to a bug report, or if you're trying to get programming help either in person or online at places like Stack Overflow or IRC chat rooms. When should you use this technique? Well, here are some scenarios where test case simplification is especially helpful. 1. When you don't know where to start looking, i.e., you can't even come up with a hypothesis. 2. When you have the opposite problem. There are too many hypotheses, and none of them seem any better than the others. 3. When you have a Heisenbug. A Heisenbug is a bug that disappears the moment you put in probes to try to observe its behavior. Now, this is rare, but it sometimes happens when you have a complex system and there are intertwined variables and dependencies, and when there are multiple things going on at the same time. 4. When you're dealing with a declarative language as opposed to a sequential one. Because it's not sequential, you can't simply put in probes to inspect the state of the program between any two adjacent lines of source code. 5. When you need a simple test case to communicate the problem to other people, for purposes that I've already previously just mentioned. That's the end of this lesson. I have prepared a couple of exercises for you to get some hands-on experience with this technique. And that's going to allow you to get a better feel for it and also to retain it better so that you can actually summon this technique for your own use when you're in the heat of a tough debugging session. In part 2 of test case simplification, I'm going to demonstrate how I solved a problem using this technique with a JavaScript source file. In JavaScript, the syntax rules are less forgiving than in HTML, and that means just cutting out half of the source code is not going to fly. Until next time.